Thanks, Bart. Thank you. Very nice. Thanks for coming. It's an honor for me to do this talk. I'm very proud of this. Proud as a Dutchman, proud as a security professional to talk about grip on secure software development. I want to explain you how the Dutch government is using this initiative to help organizations to cooperate with their suppliers on getting secure software. And in fact, this day marks the international launch of this, because initially all the publications from this standard, they were in Dutch. And recently, together with a number of system integrators and government organizations, IBM, Centric, Society, CIP, SIG, they work together in translating it to English. So now it's available in English, and if you're interested, at the door, so after this talk, you can take a copy with you. There's a standard guidebook on the method. There's a book on security requirements for applications. There's a book on mobile web applications. Now, before I properly introduce myself, I want to dive straight into the problem that we're addressing with the grip on secure software development. And I want to do this by taking you through some quotes from the trenches. I work for SIG, the Software Improvement Group, and we help our clients by analyzing their software quality and by advising them on getting software right. So we talk about software quality with developers, we talk with clients, we talk with people at operations, so we talk to a lot of people. I want to take you through some quotes that illustrate the danger that's out there, and I think you all will recognize this problem. First quote: "We assume our software supplier knows how to create secure software." And I think this is positive, it's admirable, but the thing is, if you assume and you don't write down, don't put it in your contract, the supplier will be willing to do their utter best to create high quality software, but when the pressure is high, they're going to concentrate on things that are written down. They're going to concentrate on the things that are in the contract. So you better be clear about security, but you also better be clear about what kind of security, what is important for your organization. So vague or missing requirements is one of the issues. Welcome. This one: "I thought the guys from operations would do that." This is a quote from a project. This was about patching. So there were requirements about patching, but it wasn't written in the requirements who should take care of that patching. So there was no clarity on responsibilities. We see this a lot, actually. It has to comply with OWASP, which is, I don't know if you recognize this, but it's a bit of a weird requirement. It's perhaps better than nothing, but it's not clear at all. Neither is communication needs protection. When we talk to developers, we sometimes get this reaction: we didn't expect anyone to ever check our code. So there have been much expectations about the code, but they are not used to their clients actually having their code checked. And sometimes it scares them. This one, also from a developer: "We think you'll appreciate our self-made crypto." Of course, sometimes this is a good decision to do, to implement your own security functions, and sometimes it's crypto, sometimes it's sanitization, but we see a lot of self-built security solutions. Well, at the same time, in that technology stack, there's a lot of interesting components that you can use in your frameworks. Everything, a lot of it is available. But somehow developers have the need to build it themselves, or don't take the effort to look it up, or they haven't been trained well in using the frameworks that they use. Those requirements did not apply to what we were making, so we didn't take them serious. We see this a lot. So we see clients copy-pasting a list of baseline requirements that they use for all their projects and communicating this in their contracts, in their RFPs. Now, when developers see this, it's clear to them that the client hasn't taken a real effort to be clear about security, and that they probably don't take security as serious as they should. So, I think I'm messing with the jack here. Let's put it in better. All right. So what happens is that these developers, or the suppliers, they get into an attitude where they think, well, they're not clear, they're not specific, is probably not top of mind with them. You know, we just go ahead, and whenever there's a problem, we'll talk about it, because we are at the better side of this argument. This one, developers saying, aha, did that bug lead to reputation damage? We see a lot that developers are not informed about context, about the business, about risks, threats involved. And if you do inform them, they are much better enabled to prioritize the things that they need to fix, or to pay attention to the things that they need to pay attention to. This one, we don't encrypt internal communication because that's too slow. We saw this at a client where the client explained, well, there's an internal threat for eavesdropping, man in the middle, but we don't deal with that because, well, we decided that a while ago that this would have too much of a performance impact on the network, and that's why we don't do it. But that was a decision that was made years before, and in the meantime, I mean, the world has changed, and there's no longer an impediment to, for that organization in that situation to apply proper protection of communication between systems. So the risk had been accepted, but there was no real risk management in which they revisited their accepted risks regularly. We're fine because we did a penetration test, or we have tool X. So we see a lot of reliance on penetration tests, and penetration tests are great, but they're not enough. And also much reliance on tools. And tools are great, but they're not enough, and more on that later. So these are illustrations of a danger. Before I go into telling you more about this danger, a bit about myself. So I'm Rob van der Veer, Principal Consultant at SIG. I come from the software industry. I was a programmer, I was a tester, I was an architect, sales guy, CEO, and I always enjoyed talking about making software, about the craft, the art of making software, and advising people about it. And 4 years ago, I had the opportunity to make this my full-time job, and I became a software consultant at SIG. And within SIG, we help our clients by analyzing their software, looking under the hood, how well it has been constructed, to explain what it means, economy-wise, but also operation-wise. We look at the security, and this is why we encounter so much this problem. The danger of haste. I want to dive a bit deeper into this. So what's the cause of it? How can we address it? One good way to address it is, of course, the grip on secure software development, the topic of this talk. SIG is a knowledge partner of the government when it comes to security, software security. And a few years ago, we shared our observations with the government, and this is how grip on secure software development got started. It was at the end of 2013. I want to explain how the method works. It's not rocket science, but it is one coherent collection of entry points for clients to know what to do when they want to get secure software. Some lessons learned, of course, and future work. And one of the future work things is that we want to make this into an OWASP project. So what is happening? Basically, clients and suppliers don't take the time to cooperate on software security. When you look at the quotes, you see that requirements are lacking or vague and unspecific. Who does what is unclear. No security dialogue. Proven technology is ignored. Developers are not informed on risks. There's no risk management. Tools and pen testing are regarded as panacea, and looking at code is avoided. Now, this is all, of course, there are exceptions to this, but this is the main pattern of what we see in the market. Do you recognize this? See a lot of nodding. So looking at code is avoided. Let's dive into that one. There's something going on there. For some mysterious reason, people are avoiding to look at code. There are a lot of expectations about code. It has to be maintainable in the future, in the near future, but also in the farther future. It has to be secure, but somehow it's approached from many different angles, apart from looking at the code. A lot of things in process side, activities are implemented. Testing to see whether it's probably secure or not. And when you have to look at code, try a tool, let a tool run. So it's avoided. And this is also because, of course, it's a difficult thing to do. When you visit our booth, I don't know if you have, but there's a game there called Find a Flaw. We have collected a number of notorious software flaws there. On the screen you can see them, things from YouTube, shell shock, and there's also heartbleed. So heartbleed is an error in the logic of a piece of software, and it's in OpenSSL. It was in there for a very long time, nobody saw it. It's, I think, a very good example of things that you cannot find by testing, things that you cannot find by tooling, but you really have to find by looking at the code. Another example of this is the Belgian government publishing the source code of the electronic voting system that was applied. It was, you know all about it. It was 2 years ago, I think, and I think a very admirable and great act of being transparent. But you would expect that people would be really curious and look at the code. And people were really curious, and they were also really eager to get something going, but it didn't happen. So, great opportunity, but when you look at, I think it was half a gigabyte of source code, and you have to find a way to make sense of it, it's kind of daunting. So there you go. What is this problem? Basically, I call it the danger of haste. Too much haste to pay attention to the things that you haven't agreed upon or things that are invisible. Because if you do so, if you focus on getting results, getting a system that does a thing, the quality of it becomes an afterthought. So security becomes not security by design, but security by add-on. What happens is you test at the end, you fix at the end, and at the end, the time pressure only allows you to do quick fixes. Because there's little time, the system is working, so you can finally test it, but you have to go in production, time to market, etc. And research shows that, this is of course a well-known fact, that if you have to fix things like security flaws, that in most cases the effort is a times 100 compared to the effort that it would have taken you if you've done it earlier. And this increases the first problem. The time pressure only allows for quick fixes. This is why the duct tape is on this slide. And of course, these tests are dynamic tests. They miss weaknesses. Another problem is that we see a lot of missing risk management, which is why risks are wrongfully ignored. And as a result, lower security, higher costs, and also disturbed relations between parties involved. Lawsuits, switches of suppliers, no trust. I want to make clear that I'm not saying that suppliers or developers are lazy. They're working very hard, but they're working on the things that just are more visible, that there are more stronger triggers. So the priorities are different than what I believe they should be. So what's the cause? Well, clients want software and they want visible results quick. And if you are not clear about how well things should be constructed under the hood, you create a situation where the quality is not visible, it's not checked, there is no priority for it. And what you don't measure, you cannot control. So the things that you cannot see are not top of mind. Also, clients have little experience with security. That's different worlds. And when I say clients and suppliers, I don't necessarily mean an organization asking an external supplier to build software. The same thing goes for what you could call business and IT or business and internal development department. Same issues. They're a little bit stronger with external organizations because there's less trust in general. And also, suppliers love to implement their own ideas, referring back to the "you'll love my crypto." These are things that are quite fundamental. They're hard to change. But there's one practical impediment that was keeping organizations, at least in the Netherlands, from starting that effective collaboration. And there was no shared idea on how to start and what to do. There was no book that would tell them, you need to take these steps together. There was no clear guidance on what to do. There was just a lot of disparate little guidances on different things: risk analysis, business impact analysis, requirement selection, RFPs, contracting, etc. So this is what the Grip on SSD initiative addresses. It's a standard to arrange software security without intervening with development. It's developed by the Dutch CIP, so it's a government organization, the Center for Information Security and Privacy Protection, and many others. And the many others, that's the real power here. It's not some government office writing this down. It's the collaboration between many government organizations, many system integrators, and many software security experts. The main points it addresses is risk management, it's security requirements, dialogue, having the conversation with your supplier, and some verification strategies. And it's free, it's a common standard, especially in the government. There's a lot of sharing of system integrators, a lot of shared software development suppliers. So this has become sort of common ground for this industry, this market, to collaborate. About the community, we're talking about 30 organizations in the Netherlands. So government, system integrators, experts, software improvement group is one of them. They share experience, they grow the standards together, they work on the requirements, they have new ideas and they are being shared. There's a newsletter, there are regular meetings, like sort of mini conferences, working groups working on different parts. There's a working group on mobile requirements, there's a working group on privacy, there's a working group on testing. So given these requirements, what are your test strategies? And in what situations, based on the risks, do you apply which verification strategy? And there are links with OWASP, links with the Dutch CERT, the NCSC, and with the NISA. And these are some of the logos of the organizations involved. So I think it's really, really cool that these people came together to have this conversation and to commit. Because it is about commitment. It's not just say, hey, we think this is a good idea. Because you need, if you want a system integrator on board on this, you need some commitment. So this illustrates that decision makers high up in the organizations are actually signing a manifest that says we commit to this common ground, this shared ground of ideas, and will comply or explain. And this is key because it's very hard for system integrators to commit to standards because you create a lot of, you can get a lot of issues because of liability. But when you say comply or explain, you're saying, okay, so you're working according to this method, but you can deviate. But when you deviate, you share why. So, for example, the Ministry of Defense saying, hey, but we're using another risk analysis method. But this is, of course, great input to the whole grip on secure software development, because apparently in some situations, different risk analysis methods are more appropriate. So that way you can extend. So comply or explain is key to the success, why organizations want to commit. What is in grip on secure software development? You can find it all on this URL. It's available in English, it's available in Dutch. There's a method handbook that describes the process, the things that you can do as an organization to work with your supplier with very important different maturity steps. So you can start by doing some basic things and then build up. Take the baby steps that are necessary to make this happen. And baseline requirements, so set of requirements that you can use that sort of are the bare essentials of security requirements, just to get started. And they're well defined, and they are of course mapped to existing standards. There's a verification guide, so which verification method do you use to check the requirements? There are training slides for testers, and there are contract templates. All work by the involved organizations, and this is growing and growing, which is why we want to make this even bigger and make this into an OWASP project. This is an example of one of the requirements. It's specified in a way of requirement specification that's called SIVA. And SIVA wants to make clear what is important, why it is important, what the risk involved is, what the mapping is with existing standards, and explain definitions right into the requirements. So for example, set period is explained in another specification, and automatic session termination is also explained. And it's not explained in technical terms, and that's the key here. So it's explained in terms of risks, of business issues, so it appeals to both the client and the supplier when you talk about security. It's not complete, because no set of requirements is complete, and more on that later. This is the method. Of course, I'm not going to explain everything, but it's really, you know, as I said in the beginning, it's not rocket science. It's a coherent collection of entry points, things you need to do, things that everybody should do. It's not an exotic idea. It's just common knowledge. It's gezond verstand. Common sense, thank you. Not common knowledge, but common sense. Wow, I was back in Holland for a moment. It's common sense, basically. But the power of it is that it collects all the best practices that around the world people have come up with, for example, also from OWASP, and it's referred to also for people to learn more, to read more about it. For example, with risk analysis, there's a very, of course, very useful reference to the work of Showstack and Microsoft. Security requirements are important. You need to have baseline requirements. Building blocks are important. Attack patterns, how you use them in your business impact analysis. How you can do threat analysis, come with your risk analysis, and use that to select or tailor your requirements for every project based on your base set of requirements. How to translate that into a security test plan, into how do you perform code review, how do you do security testing. Very important to manage your risks, to accept them or transfer them, etc., and keep track of this in your risk management process. Penetration testing, of course, and reporting. There's a method described in which you use a dashboard for all your applications, in which you track how well you're doing with respect to the requirements that you've identified in your baseline. And of course, external compliance reporting. And for the people that are wondering, does it work with Agile? Yes, because there's a little circle there at the bottom. What are the key best practices? Well, as I said, standard requirements, risk analysis for every project, tailoring of requirements. Be clear about your requirements, but do not try to be complete. I have more on that in an upcoming slide. Comply or explain, also for the requirements. So have the dialogue. I mean, if you're asking something for which your supplier says, well, we see it differently, or shouldn't you? Well, build this way of having the dialogue into the way you cooperate with your supplier. Keep in contact. Keep track of the accepted risks, perform penetration tests, and agree with your supplier on early independent code reviews. Put this into the contract. Hey, we would like you to have an external party have a look at your source code when we want to, just to make sure that you're doing as you're expected to. Some lessons implementing Grip on secure software development. The first start in the maturity model is to get your minimum baseline. There's a lot of that available. To get your dashboard started, to give an overview of what do you have in the chain of applications that you build and maintain, and introduce a mandatory risk analysis for every IT project. So every new IT project goes through a process in which you identify the business impact, in which you identify the risks, and you tailor the requirements for this project. Of course, you need skills. Sometimes you need to contract this or hire new people to get these skills in. You want to extend supplier contracts. That's the next step. And further mature, which means that you need to manage the maturing, manage expectations. We're not going to be level 5 grip on secure software development tomorrow. We do it step by step, and by following the included maturity model. About requirements, I referred to this earlier twice, I think. The requirements are there. The most important reason for the requirements to be there is to start the conversation and have the complier explain built into the relation with the supplier. And it's important to realize, and again, this is common sense, you cannot cover all security specific inner requirements. There's too much to cover. Security is a vast area. I mean, it's changing constantly. There are many variations. There are many alternatives to do something. So you want to pick the right level of detail in your requirements. And I think it's, I've illustrated this with this bookshelf. You see a lot of books. It's all about how to write secure software. And the security requirements are sort of, you know, the left side of it. And the rest is a gap. It's not required. With that, I mean, it's not in the requirements, but it is expected or it's suggested in the requirements. So when you do a code review, and I have more on that later, you should not just check the security requirements that were set out. You should look at security as a software quality. You should have a complete look at how well the system has security built in. Another way to illustrate this is to take you through an example of starting to say, hey, the system needs to be secure at the top, to some ASP.NET specifics on how to clean up a cache. Because somewhere between those ends, there is an optimum. This case, it's about confidentiality. So you're saying, well, data has to be confidential, stay confidential. And I'm referring to ISO 25010 because that's an excellent framework for software security. Underneath confidentiality, in this case, there's secure data transport, so data transport has to be secure. Another thing is that if you use caching mechanisms, you build them yourself or you use them from your framework, please make sure that you make sure that the data that you cache is destroyed, if it is sensitive data. And then you're starting to get into the best practices. So, for example, emptying the transport cache at a system crash. This is a detail that you don't typically see and you don't need in security requirements. Also, when it's about system type specific best practice, for example, web application, you want to clean up your cache on a request level. These are all technical details that are so, I mean, there's so much to write about. You don't want to put that into your requirements. So this is to illustrate that there is an ideal level of setting security requirements, and these requirements should then make clear what you expect the supplier to do without becoming specific about the technical details. It's a catch-22. It is. Verification. Verify the product. Do not fix the process and then hope. Of course, OpenSAM, BSIM, they're all great frameworks, MSSDL, to see whether you're doing the right activities. And of course, you should look at them. But that's no guarantee, right? You don't want to fix the process and then hope that the software is good. You want to verify the product. And by doing so, do not rely on penetration testing or tooling only. Research shows that tooling is helpful, but you can only find a very small percentage of issues in source code. We recommend, of course, to use tooling, but not leave it at that. Also, as I said, not limiting verification to the set requirements. So if you have like 35 security requirements, of course you need to check them, but you need to do more than just ticking these boxes. You need to look further than that. And if you're doing a code review, I mean, do peer review, use tooling, but be aware that good code review is a real craft. People need to have the right knowledge, the right experience. They need to know the tools. They need to understand how they can really add advice to what they see. I mean, they can find a flaw in the source code, but how to fix it or how to prevent that this flaw was there. And also, if you look at the code, don't limit the code review to security. Privacy is, of course, important. The Ashley Madison case clearly shows that you can say to your customers a lot about how you're dealing with the data, but it isn't necessarily the case. So making sure that you're actually removing sensitive data where you say you're removing sensitive data becomes really important. And the only good way to do this is by looking at the source code to see that the delete statement is really there instead of just setting a flag and that the record should be deleted. Maintainability is about how easy is it to change source code. Of course, this is important to reduce your costs in maintenance and your costs in software development. But it's also important to reduce the probability of error. So to make sure that developers are not in a situation where if they change something, they tip something else over, right? And we've seen this a lot. We've seen this recently, for example, with a client that was, there had been a number of incidents, and it turned out these data leaks were caused by improper session management logic built into the software. And the mistakes were there because when we looked at the code, it was very hard to maintain that piece of code. So it was not a security flaw, but it was a security risk, and it also already had led to some incidents and some problems. So our advice there was to rewrite this piece of logic to prevent new security errors to happen. This is to show our experience, and also this is consistent with research, the effectiveness of different verification techniques. Grip on Secure Software Development recommends to use this mix. And what you see here in the relations is that from the 8 top risks in security assessments, 4 are found by secure code reviews, manual code reviews. 2 are risks that need to be fixed by just making the system better maintainable and easier to, more difficult to make mistakes. 1 from automated static code analysis, and 1 through penetration testing. And of course, there's an area of risk that you cannot find, and this area, of course, depends on how much effort you put in this mix. And you can't apply this mix all the time, every day, every week. You have to sort of pick the right mix and the right intensity of applying the mix based on the risks of your application. And this governance of verification is what the Grip on Secure Software Development describes. To wrap up, in summary, Grip on Secure Software Development provides security by design, more security for the money, less incidents, less impact, very important, so less damage, insight into risks, a shared way of working, so system integrators, software developers, they know this set of requirements, they know the way of collaborating, so this starts to get some sort of a routine. And last but not least, better relations between the parties involved, operations, development, department, external suppliers, and clients. Future work, there are going to be more publications. Work is being done on privacy by design within the CIP. Code review guidelines are going to be released. There's going to be a self-assessment that people can do to see what maturity level they are with being a good client for getting secure software. And as I said at the beginning, internationalization. So translations have been done with different companies. It's available now. It's online now, and we're ready to increase our collaboration through OWASP and start an OWASP project. Thank you. Please.
Question on risk analysis.
Mm-hmm. So, yes, the question is, what does the Grip on Secure Software Development say about risk analysis? It's mainly about ShowStack, ShowStack based, and there's a set of alternative methods there, because it's a Dutch saying. I don't know if it translates to English, but there are multiple ways to get to Rome. So this is where Grip on Secure Software Development says, okay, we like this one. Have a look, and this is how you could do it. And if you, for different situations, you can use the other ones. So it's basically a collection of the most primary available risk assessment methods. I invite you to have a look at the document. Another question, please. Yes. Can you repeat the question, the first?
The question is, the overhead of implementing security while I am writing the code.
Mm-hmm.
The time, the effort that must be done to develop the secure code takes more time than developing the standard code, or it's just a feature that you implement by design?
Yes, so the question is, if I can say something about how much more effort you need if you want to build secure code. Well, if you want to have a secure system, then you don't really have a choice, do you? So, so if you don't want a secure system, of course it's easier to build software. You want sort of a ballpark figure. How much more effort does it take? And of course, then it becomes a business case, right? So, how much effort should you put into security to prevent your company going out of business, and what are the risks of that? It depends. I'm sorry I have to answer it that way, but I can't give you a ballpark figure there. Sorry. Yes. Or even worse with SaaS cloud service providers. Yes. So the question is, how do you enforce these guidelines on providers? Well, it's important to not be to not really interfere with the development process, because every third party has their own way of doing things, and that's fine. So you want the requirements to be on the level that they can really implement their own way of complying with it. So you want to make that as easy as possible. But of course, they need to get used to the set of requirements and put checks into place that check this. But it's better to have a standard for this than that every company tries to invent this themselves. So we see that third parties are really applauding some sort of standardization in the way these requirements have been are set out. And of course, how do you make third parties do this? Well, you need to be clear about how you view security, how you require security as a client, and I think third parties will not be surprised that you do so. So if you choose to do so, yes, your costs are going to be more expensive because there's going to be more attention to security, but your systems are going to be secure. Any other questions? Thanks very much for your time.